Hi everybody. Today we discuss purine nucleotide degradation. Purine nucleotide degradation. So the purines which are present are adenosine, guanine, inosine. Generally we have AMP which will form adenosine, guanine. To form guanine we have GMP, guanosine monophosphate, and to form inosine we have inosine monophosphate. So the nucleotides are adenosine monophosphate, guanosine monophosphate, inosine monophosphate. Adenosine monophosphate will form guanosine monophosphate will form guanine, and inosine monophosphate will form inosine. So now coming to the degradation of purine nucleotides. Adenosine monophosphate will form adenosine, guanosine monophosphate will form guanosine, inosine monophosphate will form inosine. Okay. So adenosine monophosphate forming adenosine, guanosine monophosphate forming guanosine, and inosine monophosphate forming inosine. These all reactions take place in the presence of enzyme nucleotidase, because we are breaking down nucleotide. So nucleotidase, and whenever it is a nucleotidase breaking down into the base, and there will be a release of PI, inorganic phosphate. Okay. Now adenosine forms inosine in the presence of enzyme, that is a very important enzyme, that is ADA, or adenosine deaminase. So basically we have adenosine now, we have inosine, we have adenosine now, we have inosine, we have guanosine. Adenosine is getting converted to inosine, and now we have in the picture now inosine and guanosine are present. Inosine and guanosine will both combine, will undergo a respective reaction in the presence of same enzyme, that is purine nucleoside phosphorylase. So purine nucleoside phosphorylase. So when they undergo reaction in the presence of purine nucleoside phosphorylase, a ribose 1-phosphate is removed. Ribose 1-phosphate is removed, and in turn inosine forms hypoxanthine and guanosine forms guanine. So inosine formed hypoxanthine, guanosine formed guanine in the presence of enzyme purine nucleoside phosphorylase. So till here, now we have hypoxanthine, now we have guanine. Now both will take part in inosine and guanosine were acted upon by the same enzyme purine nucleoside phosphorylase. Now hypoxanthine and guanine will be acted upon by different enzymes. Hypoxanthine, we write it over again. So hypoxanthine, we left with hypoxanthine over here, and over here was guanine. Hypoxanthine will be acted upon by xanthine oxidase, and guanine will be acted upon by guanase. Hypoxanthine forms xanthine, and Now the reaction is, the product is same. The guanine is also forming xanthine. So finally we have xanthine, which is formed by the metabolism, the breakdown of all the purine nucleotides. So hypoxanthine forms xanthine, guanine forms xanthine by the enzyme guanase, and now this xanthine is again acted upon by xanthine oxidase to form uric acid. This is the breakdown product of purine metabolism, that is uric acid. Now the speciality of xanthine oxidase is that it is exclusively present only in liver and small intestine. If we see very clearly, xanthine oxidase is the final reaction, is the final enzyme in the final reaction that leads to the production of uric acid. So in cases where uric acid increases, that is, there is increased concentration of uric acid in any condition, we can give a drug which will inhibit xanthine oxidase so that uric acid is not formed. We'll see now more details about xanthine oxidase. Xanthine oxidase is an enzyme. Xanthine oxidase is an enzyme which is present only in liver and small intestine. Only in liver and small intestine. It requires FAD and molybdenum and iron and it is inhibited by the drug allopurinol. Okay, so allopurinol, how does it inhibit xanthine oxidase? Allopurinol, how does it inhibit xanthine oxidase? Allopurinol is a competitive inhibitor of xanthine oxidase. Allopurinol is a competitive inhibitor of xanthine oxidase. So it does allopurinol when it reacts in the presence of xanthine oxidase, it forms alloxanthine. And it is a more effective inhibitor of xanthine oxidase. So this is also an example of suicide inhibition. Okay, so these generally, it is said that uric acid concentration can be increased in conditions such as gout, but it is not necessary that the uric acid concentration would be increased in gout. It could be of normal level also, or it could be decreased also, but it is considered mostly to be increased. Normal uric acid concentration is 3 to 7 milligram per dl. Normal uric acid concentration is 3 to 7 milligram per dl. It is increased in cases of gout, but it is not a necessity that it will always be increased in cases of gout. Uric acid in primates can be converted to allantoin. Uric acid in primates can be converted to allantoin, and it is non-enzymatic reaction and in non-primates it can form allantoin again, which will undergo further metabolisms to lead to formation of different products. That's all for purine degradation or uric acid formation. Thank you.